Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of pgMustard. This is my co-host Nikolay, founder of Postgres AI. Hey Nikolay, what are we going to be talking about today?
Your time to announce. My time to choose, your time to announce.
Anybody following you on Twitter probably saw your tweet this week that got a couple of hundred retweets, a lot of likes, and it was a summary of tips for beginners, you said, right? So 10 tips for people that are new to Postgres. So we thought we'd discuss that.
New means probably people use Postgres for a few years already, but never, you can be developer, you can use some backend developer or even front-end developer sometimes. You can you can use some ORM, Rails, Django or something, maybe touch some SQL sometimes, but consider Postgres as some kind of black box, relational black box, But at some point, of course, it's worth understanding at least something, like to scratch surface and understand what's happening under the hood, just to avoid bad surprises, like why my delete is so slow, or why it's behaving like that, like why I deleted a lot of data, but disk space consumption is still the same, right? Or why bloat accumulates so quickly, and so on.
Yeah, so I think you're right. I think some of these will be useful to people, even people that have been using Postgres for years. But I also think some of them will be really useful to people that have only picked it up recently or whose organization are migrating to Postgres from another database. So I think there's a whole range of people that are new to Postgres, or even I've enjoyed reading these and, thought, oh yeah, I do need to look into that. I've never installed that extension or something. So yeah, there's a...
Right.
For me, there were a few things.
Right, but as you very rightfully, very correctly noticed, all of these things we already discussed. So every one of all those 10 tips can have a link to our previous episode for a deeper dive, right?
Yeah, absolutely. I think some of them aren't the exact same topic, so I'm interested to ask you a couple of questions on a few of them. But yeah, I'll include links to episodes for people that maybe people that are newer to our podcast and haven't listened to every single episode we've done.
Right, and from there you can go to very beautiful blog posts, articles, talks, and other books, and so on and so on. It's like you can use this episode as an entry point, other episodes as like deeper entry points to specific topics, and from there you can learn a lot. So it's kind of like a tree, right?
Yeah, absolutely. Right, so I mean, we don't have that long to discuss 10 things. Should we get started?
Yeah, let's go.
So the first one on our list is all about tuples. Do you want to give the summary of this?
Yeah, so it's I don't know why everyone continues mixing. Not everyone. Many people continue mixing rows and tuples. Tuples are physical version of rows. It's MVCC model, a multi-version concurrency control model Postgres uses, and you can feel them if you look into secret columns, well, not secret, but invisible columns, CTID, xmin, xmax. And we discussed it, right? So CTID is physical location of this tuple. Again, tuple is a physical version of row. So if you change it, physical location usually also changes. Well, in most cases it changes. And CTID consists of two parts. It's page number and internal address inside page, so like offset. And my usual trick, if you need to extract only for page number, for example, you convert it to point data type and then address it like X or Y component. So X is page, Y is offset, and then you can extract it and convert it back to number, and that's it. So it's easy. Because this like CTID data type, I think it lacks some operators or something, or functions. By the way, maybe it's a small addition that could be first contribution to Postgres if you want to try to writing some C code. It's quite simple. So yeah, and so this CTID is interesting, and it's it's my favorite trick, one of my favorite tricks to surprise people, like saying update table set ID equals ID, where ID equals 1, and you suddenly see that CTID, this hidden column, changes its value, even if logically you didn't do anything. But Postgres copies whole tuple each time you change it. Right.
Yeah.
In the best case, it can happen inside the same page, and so you don't receive index updates. You don't need to update all indexes. In the worst case, it goes to different page, and all indexes should be updated. Unfortunately, receiving new entries. And xmin, xmax, it's like date of birth, date of death, right? How to say in terms of transaction ID. We discussed it, right? We discussed it. We have episode about MVCC or bloat or so and so on. It's all related.
I think the episode we discussed this most in was our other more beginner-focused episode, which was how to become a DBA. So I think I'll link up that one for sure. And I thought it was a great tip. I had nothing to add. I think it's quite simple as well, and you've gone into good detail. Should we move on?
Right, but I'm quite sure that this should be clear not only to DBAs. This knowledge should be clear for everyone who works with Postgres, because even if these columns are hidden, you inevitably will deal with bloat, with slowdown, with some slow delete, some slow update, massive update, for example, and so on. And understanding this starts with understanding what tuple is.
Yeah, I completely agree. It's going to be coming up again in a couple of the later tips as well.
Because DBAs usually don't write most of the code. Most of the code is written by developers, and if developers don't understand that update set ID equals ID leads to physical action, quite expensive one, they will continue writing it, right? If they understand it, they already will avoid it because they understand what's happening under the hood.
I agree.
Okay.
Number two.
Number two
is one's close to my heart as well, isn't it? Always use buffers when checking, explain, analyze.
Yeah, we mentioned it so many times. If it's not your first episode, you definitely know it, and nothing to add. But if it's first episode, just remember buffers should always be inside parentheses with analyze when you write explain, analyze. So analyze should be in parentheses, comma, buffers. Explain. Don't use an explain, analyze. Use explain, analyze buffers always.
Well,
no
I was gonna add to it. I think, especially if you're brand new to using explain and you might have to ask a colleague or somebody online for help, I would also recommend when you're getting the explain plan to use verbose and settings as well. They're two more parameters. Verbose because it gives the people reading it more information about your schema, as well as output columns and things like that. So more information for people that aren't as familiar with the query that you're working with. And settings because if you've changed anything locally, that will show up, or if you've configured the database differently to how production's configured or something like that, those things will show up and they'll help people avoid wasting time when helping you. They might spot an obvious issue in there.
Yeah, well, yeah. So deviations of settings. But I also verbose will make it verbose. If you write JSON, format JSON, it will be even more verbose and so on, but more difficult to consume by humans. But I also think sometimes it makes sense to turn off costs, for example, if you just care about execution in some cases, and you want a narrower output to share with your colleagues. In some cases, it makes sense to remove costs. But of course, costs are very important to understand what Planner is doing.
As a beginner, I wouldn't be doing that, just in case somebody helping you can.
Right, but if you verbose, it's so wide and long and so on. I just see sometimes people share plans with cost off just because they want them. The place where they share, if they don't do it, it's hard to read the plan if it's textual. I
kind of disagree, but buffers, for example, in JSON format, buffers add 12 keys per node, so that's a lot more than verbose is adding.
Well, okay. I just noticed quite experienced guys do it. Costs off. I also started to use it sometimes, especially if you already collected a plan without execution using just explain. There is no reason to repeat the same information in subsequent plans, right? If it's the same plan, but sometimes, of course, you add index plan changes. So if you don't use costs, then it's hard to compare and understand why planner chose this, what planner thinks about costs of particular nodes inside the plan. Okay, I agree with you, but sometimes still okay.
Let's move on. So always use buffers. No matter what else we've just said, use buffers. Number 3, you've said throw away pgAdmin.
I said it many years ago, and I keep saying the same. So
why? Tell us why.
Many reasons, and where to start? Okay, this is my personal opinion. Same opinion I have, for example, about Windows, but I understand that some people like Windows, so it's okay. But in this case, I see that it's not only my opinion. Every person I talk to says the same. But pgAdmin stays on, takes very important stage. It pretends it's official Postgres UI, graphical UI, right? But it's a separate project. It's developed by not the same people. It has different release cycle and so on. And I think it's advertised unfairly, and it forms wrong expectations, because the quality of this product is not good. That's it. It has a lot of issues, UX issues first of all.
I think you're right. I think there are better free and even open source graphical user interfaces available. I think you're right also that because it comes with a couple of the officially linked to distributions. So if you download Postgres for macOS or for Windows, pgAdmin comes bundled, which does lend itself to believing it's default official. But equally, I was looking at the Stack Overflow survey results recently, and I was seeing that even though Postgres has gone ahead of MySQL in terms of popularity and in terms of even usage for professional developers, when people are learning to code, it's still a long way behind MySQL. And I was actually thinking that one of the reasons is, I think it is useful for beginners to have a graphical interface in a lot of cases. So I can see the temptation to bundle one. But yeah, I think this is good advice, and there are good alternatives, which is really helpful.
Yeah, there are a lot of alternatives, and just check opinions. Don't trust me. Check reviews, opinions from others, and you will see so many people don't like pgAdmin, especially then they already saw something better. There are some better tools.
Yeah, we've got a whole episode.
But main advice from me is learn console, PSQL, and Tmax and VI, and maybe even without VI, some people just use Nano and that's it. It's enough for them. PSQL is something worth learning. Even if you spend most of your time in UI, you will still benefit from understanding some PSQL tricks, because CLI it's more. It's better for programmers because you can code something in it. You can make your colleagues repeat the very same steps you did, right? Because it will be a script.
Well, more than that, it's also Postgres quality. It's also shipped with Postgres, written by the same people.
A lot of people, same people, many same, not the same people, but a lot of people who work on Postgres engine itself, they work also sometimes on PSQL, and it has so many features. It has the same release cycle, the same quality, same. It's PSQL is definitely Postgres native tool. Yeah. pgAdmin is not native tool. It pretends to be native, but it's not.
One counter I have heard to this from a few people that have also said they prefer other interfaces is that they still use pgAdmin for its PL/pgSQL debugger. So I don't know of another tool that has one built in.
I think you can use Tmux and VI and still have debugger. It's hardcore approach. I personally don't use debugger, honestly. I just use print lining everywhere. Somehow I used debugger in many languages and environments quite like often, trying to pretend it works. But somehow always like print lining is always with you, always. And if you know how to do it right, and in PGSQL there are approaches how to do it right. For example, you can raise debug, for example, right, and or raise log, raise info, raise notice, raise warning, raise exception. Although it's an error, but it's called exception. You can catch them. In this case, you will deal with subtransactions. Also, interesting thing. I have an article about subtransactions to warn about their issues under heavy loads. But print lining is always with you. It's always working. Maybe less convenient, maybe a little bit more time consuming in some cases, but it's good. So debugger, I respect debugger, obviously. Like debugger is a great thing. It's like professional level, right? But still, like I personally don't use it, so I cannot recommend. But like to be fair, pgAdmin also has schema diff component, for example. Yeah. I looked into its code. It's quite interesting code, and you shouldn't expect magic there. I mean, it's schema diff. It will produce some DDL to convert one schema to another without context. So you might have issues if, for example, you rename column versus you drop and add column, so data can be lost. So you should be careful with these steps. And also, of course, it will be DDL, which is written in non-zero downtime fashion. And I don't see anyone who implemented zero downtime diff in terms of DDL. It's a hard topic. But others also, some other UIs also have component for diff.
Yeah.
Also, pgAdmin has good component to work with GIS systems and present some data on map. I just saw people using this quite well. I personally don't do it, but yes, it has some good features. I think dbeaver also has it already, right?
That's actually when you look at comparison discussions online between the two or between various GUIs, the one that comes up most often for praise when it comes to displaying graphical information is dbeaver. It's what a lot of people love about it.
So, but bottom line, I personally don't like pgAdmin at all. I think it's should be replaced everywhere, and but I'm not alone. And if you don't trust my opinion here, just check other reviews. That's it.
Yeah.
Just check them.
Next, let's move on.
Let's move on. Next is settings, logging settings, right? So logging is super important, and usually when you need it and you find yourself working with default logging, and something happened and you don't see it, don't see data. So you should enable logging of checkpoints, of autovacuum. I recommend to log everything. Of course, if you have a lot of tiny tables and autovacuum constantly touching it, writing like, okay, I just processed like 1 megabyte table, small one. It's maybe spamming your logs, but it's still worth understanding some details usually and so on. Like I usually recommend enable logging for all autovacuum occurrences.
Yep.
And temp files, I also prefer logging all temp files. Log waits, which is based on deadlock timeout, which is by default 1 second. Some people tend to increase it. It's like it's for deadlock detection, but it also indirectly defines how events of being blocked by other session will be logged, right? Blocked, logged. So in this case, also this is by default disabled. So if some logging issues are happening in logs, you don't see them, unfortunately, and that's bad. I prefer seeing everything here, so just enable it, and every time some session waits more than 1 second, by default, deadlock timeout, you will see it, details about this case, and it will help you improve your application code and so on. And also logmin duration statement. Well, sometimes it's okay to set to 0, but very rarely, because to log all queries with duration, to log all
I'm shaking my
successful
head.
queries. Well, there is opinion we should have it. For example, if you have Nginx, for example, right? It's normal to log all requests to HTTP server. I mean, Nginx, for example, right? HTTP server. We log all requests. Why with database we cannot do log all requests? Because usually, especially if you put, if you use syslog journal D, and also you put your logs on very some magnetic device. Well, it will be sequential writes. It's not that bad usually, but still, if you can do the math, how many IOPS and megabytes per second you will need to have, right? But so observer effect is no joke. I put very important production systems a few times myself down. Put them down multiple times, and it was a super expensive experiment, and the lessons learned were very hard. I wouldn't do it on serious production. I mean, putting 0, but trying to go down, definitely yes.
Well, and setting it to something, I think, is the key here. Like setting, obviously, not
-1, you mean?
Yeah, something positive. But there's a value that anybody can afford here, right? Like there's
5 seconds, 1 second.
It'd be right. So like, if you can't afford to do that, you've got bigger problems,
right? But, because if everything is slow, it won't be so many queries
you can't have that many, exactly.
Right? But I think it's super fast. But still, you need to learn your observer effect. Understand these capabilities where you have logs, and maybe test it and understand. Okay, we are okay to log maybe 10 log entries per second, for example, normally, and maybe like 100 during peak times. It's okay for us, for example. Or maybe we should adjust settings and raise some bars like log duration statement or log autovacuum min duration. We can also raise it a little bit and so on. Yeah.
Wonderful. Shall we move on?
Yeah.
So it's quite related. Still looking at performance, but also here a bit more logging. We've got install pgstat statements, which is a must, you've said, and if you can, a few more extensions: pgstat kcache, pg wait sampling, auto explain. Even you mentioned pg sentinel here as well, but with a few extra decisions on settings for those last few.
Right. So pgstat statements should be everywhere, installed everywhere, and overhead is very low. We had an episode about it, of course, and other extensions are these pieces of advice are mostly for people who manage Postgres themselves, because cloud providers usually provide something extra to pgstat statements. For example, RDS provides performance insights, so you don't need pg-wait sampling. But they don't provide anything similar to pgstat kcache, which gives you physical angle for query analysis, unfortunately. So you cannot answer who is responsible for high CPU consumption, which query is responsible for high CPU consumption. You can only indirectly answer this. With pgstat kcache, you can directly answer this. So these extensions are good things. But auto-explain is everywhere, right? Auto-explain is everywhere.
It is now. Yeah, we had an episode on that as well, where I claimed that it wasn't on Heroku, but then the next day it was available.
Heroku, I remember this. And worth reminding, you have an article saying that sometimes it's okay to enable timing option for auto-explain, and of course we want buffers there. Also, both have some overhead, and your post was about unlike common opinion, sometimes this overhead is not huge, and you can enable them both probably. Not always.
But also never with a threshold of 0 milliseconds.
Oh, right. So again, it's only for slower queries. But slow down. 0 is fine if you use sampling. And
maybe.
It was you who told me that sampling in AutoExpand exists for already many years, unlike slow query logging component, which is log mean duration statement based. Now we have, in modern Postgres version, we have sampling capabilities for both AutoExpand. And these things are like, they compete. If you choose AutoExpand, you don't need log mean duration statement because, well, we discussed this. Like, let's keep details for those who are interested, and we have a link to episode where we dive deeper into this topic.
Perfect. Let's move on. What's the next one?
Let's move on. So my opinion is that all development should happen on larger data sets. It should happen, like, you should see, it's not worth wasting time developing on small databases, on empty databases. Just take bigger size, realistic size clone and just develop using it. Of course, you should remove PII, personal identifiable information, like phones, SSNs, emails, and so on. Because if you use it for development, some auditors won't be happy if you use production clone for development. But not always. Sometimes people are okay to clone. In many projects, it's fine because you might work with just public data, for example. But my idea is, like, I see people tend to develop with small or like fake, some mocked databases, and then they are surprised why some queries work slow or don't work at all.
Yeah, exactly. I think people are surprised not only that more rows can be slower, but also that it can affect planner decisions quite so drastically. Even whether, I think people understand that join algorithms depend on data sizes, but they don't always realize that scan operations can depend on it as well, and all sorts of planner choices. But it's even not just query performance, right? It's also spotting locking issues. If you have a tiny table, you might not spot something that's taken an exclusive lock that's going to cause you downtime if you apply that in production. So I think it can help you with spot other issues as well by doing this. I think it's a good tip.
Right, but even not related to performance, if you develop using some, like, if you present your feature to your product manager or project manager or some QA specialist or some other people, not engineers, not necessarily engineers, and it has some random data, you cannot, you don't have good page navigation, search doesn't work, and because you just generated a few rows, that's it. It's also not working well. Unlike compared to the case when you have production clone with PII removed, or you generated really more realistic data sets, and you can share a clone quickly using Database Lab, for example, database branching, like cheap and fast. You can share it, and they can dependently test it. It's very good. It unblocks many not clear in the beginning processes inside development process. But I also wanted to say that the idea of using large databases sometimes conflicts with the idea I want to take my laptop and go to some vacation or work on plane where internet is slow or so. So people, of course, want to have database on their laptops, on their working machines sometimes, to avoid the need to use internet connection. And I understand that, of course. And in this case, if you want 1 terabyte, well, probably today we'll already have disks with like 1 terabyte. Sometimes you need subsetting, of course. So you need to minimize, but still, you can work with more realistic data. And if you can have 1 terabyte on disk, but clone it 10 times without extra costs and in terms of money and time, this is how things should work. And worth noticing, we have copy on write everywhere already. We have it containers, it's copy on write on file level, layer FS over layer 2, like this. When you create container based on some image, it doesn't copy everything because it's copy on write. And we also have Git. Git is also copy on write on file level. You create branch, it doesn't copy whole repository, right?
Yeah.
It just virtually creates like a copy, but you share the same files among all branches which are the same until you change some file, right? Same here. You need to develop applying copy on write to databases, and this is exactly what we implemented, trying to help people. I mean, we Postgres AI. Mm-hmm.
Yeah. You've spent a lot of time thinking about this. We did a whole episode on it. I think the database branching episode is the best one to share here, so I'll do that.
Good, yeah, agreed.
Nice. So we've got a few more, but luckily some of these are shorter. Make sure data checksums are enabled. So this is about avoiding corruption, and we've got a whole episode on that, right?
Yeah.
Anything additionally to add there?
Well, unfortunately, the databases created a few years ago probably don't have them enabled, and I think still Postgres itself has default off because it should be done during initdb time when you create a cluster. Of course, they have overhead. Everything has overhead, but this overhead again worth having. Yeah. Because without them, risks are high, and it's hard to you need to implement a lot of additional procedures to control your corruption risks. And somebody, by the way, asked about if you have checksums on lower level, for example, if you have ZFS, like Database Lab, because it uses ZFS as well. In this case, probably you don't need data checksums. I think we have data checksums in Postgres level are at higher level. They protect not only from hardware issues, for example, when data is corrupted and data checksum says, okay, I expected to read something, but I see this page has something else. So we have corruption. I think it also protects from particular, maybe not very likely, but some bugs in Postgres itself or in file system itself, because checksumming at higher level feels more safer to me. You created some content in shared buffers, you have checksum, and then everywhere, like Postgres itself, file system, personal system, and then hardware, all of them are under control. If you do it at lower level, you have some layers of your system which bypass that checksumming, right? Maybe of course it's already good if you have checksums in file system, definitely good, but it feels not as complete as Postgres would do it. Corruption can happen in many places.
Yeah. If we remember this is for beginners, I guess a couple of other things to mention that I think we cover both in the episode. I can't remember. One is that you could do a smoke test to see if you've definitely got some corruption, for example, in some of your indexes using amcheck, and you can also
use amcheck for heap. And if you just open documentation, it was a surprise for me a couple of weeks ago. Amcheck is officially for heap as well, because it has...
really?
Yes.
Cool.
It has pgAmcheck, which has parallelization option, -J. You can use multiple jobs and move faster, of course, using more cores and put more pressure on your disk I/O system. So you can say heap all indexed, some flag, heap all indexed, as I remember it. And in this case, if all your tables have unique keys or primary keys, which cover whole table. Primary key covers whole table. Heap will be checked as well.
Oh, great.
And in this case, you don't need pgdump to def null anymore. Yeah. Because it turned out, I started recently how to run pgdump to def null in parallel. And it turned out not to be so trivial. So, and then someone basically, Andrei Borodin told me that pgAmcheck can be used for checking everything, both indexes and heap. And that's great.
Nice. The other thing I wanted to mention is that some backup tools have the option to check for corruption at backup time, which is quite nice if you can't. If you've already, yeah.
But is it checking corruption in database or in backups? Corruption can happen in many places. Yeah. This is the main rule of corruption. It can happen everywhere.
I think it checks it at the database level, but I could be wrong.
It should be used something existing like amcheck. Worth looking into it. I don't know it. It's interesting.
Should we move on?
Yeah. Next, number 8 is tune autovacuum to run frequently and to make it move faster. Yes. default are bad. Default settings are not good enough for you usually. In most modern cases, although recently it was adjusted, like a few years ago, default settings were adjusted. Cost limit, cost delay. Cost delay went down to 2 milliseconds from 20 to 2. So 10 times, 10 times more quota in terms of CPU and especially I/O. And now it can a single worker can move faster, and so many things inside this autovacuum tuning. Basically, you need to move it faster. So because by default it's also throttled, so throttling and also frequency of occurrences. By default, it happens like with 10%, 20% of tuples affected. It's too infrequent. It's too conservative. For OLTP, you should use like 1%, half a percent. So make it 10 times, to run it 10 times more frequently, or even 20 times more frequently, and so on.
Yep, completely agree. We've got a whole episode on vacuum. I think that's worth people checking out if they aren't aware of this. But yeah, the best analogy I ever heard was vacuum's a bit like exercise. If it hurts, you're not doing it often enough.
Right, and I usually say if you, for example, update, deleted, all insert with rollback something, you produce some dead tuples. You put some pressure, and if you have 96 cores, 128 cores, and all your cores can do that, right? They can do writes and produce dead tuples. Why do you have only 3 workers? 3 workers is not enough to clean up after all those guys, right? You should allocate like at least 10% of your cores, like 10 workers or maybe 20 workers to clean up faster, because a lot of work done, a lot of cleanup work should be done.
Yeah, and the bigger your tables get, the worse the default settings get for them in terms of those scale factors. So yeah, good.
You
really
partitioned, but didn't change autovacuum workers number. It's
True.
still 3, but you partitioned. Well, it's not good as well. You cannot benefit from having a lot of cores, maybe. So yeah, it's an interesting topic. We definitely discussed it, but this should be done by all, because defaults are not enough in most cases.
Agreed.
Your topic,
Next.
query optimization.
Yeah, this is probably my favorite. I actually looked back and we've done 2 episodes on this one. So the introduction to query optimization and we called it 102 on it as well. So I think obviously I liked your tip here, but it's that query optimization will eventually be more important than config tuning.
Yeah, so, config tuning is enough, like 1 per year. Query optimization should be done every time you you perform a lot of changes in application. So if you tend to have a couple of releases per day, you need a lot of optimization activities.
Yeah, I've seen quite a few people end up throwing money at this problem instead. Instead of tuning a few queries, they scale up the database.
People think configuration tuning is something like silver bullet. No, you change infrastructure level quite infrequently. For example, you upgrade your VM or you move to different infrastructure, upgrade your operational system. In this case, you need to reconsider Postgres settings. But usually you done it like 50-80 approach. You did good enough job. It's not worth spending time to fine tune it further and further. It won't pay off. But if you have very frequent releases, you have big instability in this area. Fortunately, usually it's not so wide as configuration tuning. Configuration tuning usually it's like global. You changed work mem, default work mem, it will affect all queries. In query tuning, usually it's very narrow. Okay, couple of tables, several queries working with those tables, so you can scale this process and involve more people into this process, especially if they all have independent clone databases. I won't stop saying this because it's obvious. Everyone should have their own big size database.
Yeah, and again, going back to previous tips, pgstat statements makes this a lot easier as well.
Yeah. Well, from top to bottom analysis, yes, I agree. Okay, and last tip is about indexes, and I found it interesting that people don't realize that index health declines over time. Even in modern Postgres, even with all deduplication optimization happened in Postgres 13 and 14, if you have Postgres 15, the latest major version 15, even with it, over time, index health will decline because they receive a lot of updates. Not in all cases they can rebalance, right? They receive some bloat still. It's much better with newer Postgres, much better than before. Postgres 12 is much worse than Postgres 15 in this area. But still you need to reindex them occasionally. From time to time, you need to reindex them, and you should just control bloat using some bloat estimate queries. They will produce some numbers with some mistakes sometimes, like up to sometimes I saw 20-30% is mistake. It says 50, but it has only 20% of bloat. It's okay. I mean, we can reindex them, but reindexing is heavy operation, and it requires two things: disk I/O, and it also requires some brief locking. And it can be blocked by autovacuum running in transaction ID wraparound prevention mode.
Yeah,
so
true.
Yeah, you need retries, you need to be careful, and usually you need to put this additional work on some like weekend or night time. But it should be automated, and I think it's already obvious that we need some better tooling. And it's a shame that cloud providers don't provide additional tools to automate this work, because almost everyone needs it. This is another popular tweet which got a lot of likes when I criticized cloud providers because Progress went in the wrong direction, in my opinion, because they implemented backups, provisioning, replication, auto failover, and then jumped to very exotic topics like serverless. And they left us with all these needs alone, basically, like query analysis, index maintenance, autovacuum, some autovacuum related work, bloat analysis, repacking, and so on and so on. And monitoring in cloud providers has very slow progress as well. Like down to earth topics, not exotic ones. It's very great that we have a lot of progress on the like frontier of exotic topics, but we still need to close some gaps in administration, and I think this is one of them. Index maintenance, also unused indexes, redundant indexes, invalid indexes. Sorry, I cannot stop here.
We've got a whole episode on this for anybody new to this topic. I'll link that up. But yeah, I do want to give a shout out. The work on Postgres 13 on deduplication, and I think on 14 on bottom-up deletion is wonderful work and has massively reduced this problem, but it still exists. But it does mean if you're upgrading, like I've seen quite a few people lately doing upgrades from like 11 to 15 or 11 to 14. So those people, especially if you're upgrading in a way that preserves your bloat, definitely worth looking into reindexing as part of after your upgrade, because you might get significant savings and speed ups.
Okay, you mean reindex all indexes to be in better shape, because these optimizations will work only after you rebuild your index, right?
Will the optimizations work only afterwards? I'm not sure, but basically
some kinds of optimization definitely will work only after you create new index. So you need to rebuild it. Yes.
But the damage is already done, basically. So it's going back to the start, and then it won't degrade as quickly in the new version. But you'll also get that initial boost.
Right, but the main idea, you need to index anyway, for newer Postgres, and I don't think it will. This need will go away in the future, because looking at other systems like SQL Server, for example, they also have this need.
Okay, I didn't know that.
Index maintenance, meaning we rebuild index sometimes. Of course, index maintenance also means we clean up unused indexes, redundant indexes, but also we rebuild indexes which health is not so good, meaning bloat accumulated. This is normal.
Nice. So these were your 10 tips. I've actually got a bonus one I wanted to add. I think not all beginners realize that the Postgres documentation and release notes will be as good as they are. And even the source code, the comments in the source code is really accessible even to beginners. So those things are your friends when you're trying to work out why something's happening or what the truth should be. So yeah, documentation, release notes, and source code comments are all brilliant.
And the README files in source code as well.
That's good point.
In some directories we have README files, and they are quite good at plain English, explaining things not explained in documentation sometimes.
Yeah, completely agree.
Good. I also completely agree. I think it was good. I think it was helpful for some people. Please share your opinion, and don't forget to share this episode with colleagues you think might benefit from listening to this episode. And till next time, thank you.
Much appreciated. Take care. Thank you.
Bye-bye.